This is Algebra 1, Term 5, Lesson 5, Real Numbers. We'll start with GeoGebra tasks. We'll then move on to a Desmos classroom activity, and we'll finish up with some applications. So in our slides, we'll go to a GeoGebra task by clicking this link. And in this activity, we're going to see if students can remember how to place their real numbers into a Venn diagram. So they will grab the labels that are here. They will pull them up into this set, and they'll only fit in certain places, so I don't want to do it for them. Once they have placed all of the different types of numbers into the Venn diagram correctly and checked it and it is correct, they will take a screenshot and place it on this slide. And then they'll move on to the second task. In the second task, they have 4 different images that they're going to need. So they're going to go to GeoGebra at this link, and they're going to classify real numbers. The image that they paste in the table here needs to be a natural number. The image in the top right needs to be rational number, and the bottom left needs to be an integer, and the bottom right an irrational number. So they will have to do enough items until they get at least one of each of these types. Once they're finished with task 2, they'll move on to the next slide. For task 3, they will simply do 5 correct problems, and then they'll be able to move on. So what we're going to do is drag this number to its correct location on the number line. So wherever they think it goes, and then they will check. They have up to 3 checks for each of the numbers. As soon as the number correct down here says 5, they will screen capture that number line with the number correct on there, and they will put it on their slide. Once they finish the third task in GeoGebra, we're ready to go to Desmos Classroom. So in Desmos Classroom, we are looking at specifically rational numbers. There are a few questions in here with other numbers, other types of numbers, but most of this activity is dealing with rational numbers. And so on the first screen, they're given a rational number, 11 over 2, and shown that it can be written 2 other ways. 5.5, 5.5, and the number 4 over 6 can be written 2 other ways, 2/3 and as a repeating decimal. On these next two, they're to write them in 2 different ways. What's another way to write 10/3? And they need 2 more ways, and then 2 more ways to write -6/8. And then the definition of a rational number is here on this screen. They will be seeing it over and over on the first few screens. Okay, now this one we're going to learn how to convert a repeating decimal into a ratio of 2 integers or a fraction. And they will use a system of linear equations to do that. So this is the traditional way of converting from repeating decimals into fractions. Okay, they're going to use the same strategy again, this time with the repeating decimal 0.44444. It is rational, so we're kind of proving it's rational by showing that it is the ratio of 2 integers. And then they're going to try it again, and this time with 0.9999. This one is a little bit unexpected. It's one of those that kids go, what? Every time you do it. So they're going to do the same strategy again, create a system of linear equations and solve them to find the ratio of 2 integers. All right, now we're going to do some classifying. These are self-checking. When they do get them right, they will get a little message that tells them it's right. So let them know if you're not seeing a message saying you're right, you need to keep trying. They will check all that apply. Now, one of the misconceptions is a number with a square root symbol in it is automatically irrational. That is something a lot of students assume, but that is not true. So they would first, of course, need to simplify this expression to see what it is simplified, and then they can make a better judgment as to what type of number it is. On this one, they're going to match them up. They have always, sometimes, and never. I would spend probably quite a bit of time on this and have lots of discussions. Have the kids talking about it in their teams with each other as they work through this. Yeah, this is really an important slide because this really gives you insight into whether they truly understand what it means. Here is Marcello thinks that rational numbers are integers. Is he right? Yes or no? Once you answer this question, there is, it does say explain your thinking. Lanny thinks the square root of 18 divided by 2 is rational. And then what is Lanny thinking? So what might make him believe that it's rational? What could he be thinking to think it's rational? Is this sum rational? The square root of 4/3 plus 5/3. Once they've chosen yes or no, then they need to explain what both of the numbers are individually and what the sum is. On the next screen, they want to know if the sum is rational. Classify each of the numbers and then classify the sum in the explanation. Is this sum rational? And then this one says, is the product irrational? So we've gone from adding the numbers to multiplying the numbers. And again, we're multiplying two numbers. Classify each of the numbers and then classify the product. And then on the last screen, they're kind of summing it up. We've got rational and irrational. So we're going to put all the rational numbers on one side and all the irrational numbers over here. And it is a self-checking activity, so they'll know if they have them correct or not. A lot of kids will just look at these numbers here and kind of ignore what they're seeing on these cards. Unfortunately, that's a bad side effect of having it self-checking. So you may want to stop at the end of the activity and just do some little Q&A. Why is this rational? Tell me what you're thinking. Why is this irrational? And have them talk about it and not just do the card sort, because they do need to talk about it. Once you're done with the Desmos classroom activity, you're going to head on back to your slides. There are 3 application problems. They're asked to solve the problem and classify the solution. So we have a sleeping cat that is startled and jumps up into the air with an initial velocity of 14 feet per second. How long will it take for the cat to return to the ground? Next, Maxine serves a tennis ball. Now this one is a little bit culturally sensitive. Some students have never played tennis, and there may actually be students that have never seen tennis played. So if that's true, you might need to show them a video or, talk about it, maybe get some pictures up there to talk about what it means to serve a tennis ball. She served it at an initial upward velocity of 9 meters per second. Her tennis racket strikes the ball when it's 0.5 meters. Well, that's pretty low for a serve, so she must have done some kind of underhanded serve. But if her opponent misses the ball, how long is it going to take for the ball to reach the ground? So the opponent's supposed to hit the ball with their racket, but let's say they missed. And how long would that take for that ball to reach the ground? And finally, a boy throws a ball up with an initial velocity of 46 feet per second and releases it at a height of 6 feet. How long will it take for the ball to return to the ground? So we're doing really the same problems 3 times in a row, but please note that not all of these are using the same units of measure. This one's using feet. In Maxine, it's using meters. And for the cat, we're using feet. So we're kind of toggling back and forth between the 2 vertical motion models. We've been using that a lot, as you've noticed. It's I guess it's a real versatile tool to use. And that concludes our lesson, Real Numbers. Next time is our first test in Term 5. Y'all have a great day.